The human brain. It's just, it's astonishingly complex, isn't it? This whole universe inside our heads, electrical signals, chemicals, doing everything from composing music to thinking about space. But even with all that mystery, we humans, we really like to simplify things. We want to see them, make them graspable, even the really big stuff. And that kind of impulse, that's really what we're diving into today. We're looking at something, well, fascinating, maybe a bit unsettling. It's a brain seizure simulation. Yeah, you heard that right. Yeah. An interactive tool lets you see and even hear a representation of a brain seizure for educational purposes.
It's definitely a compelling idea. And what's great is we're not just looking at the public website stuff. We actually got a peek behind the curtain. Some developer notes, discussions from when they were actually building this thing, gives you a real sense of the nitty-gritty decisions they made, sometimes kind of ironically meticulous decisions.
Right. So that's our mission today. Let's unpack how this thing tries to show seizure activity, what it's very careful not to claim it is. And those warnings are loud and clear.
Yeah.
And maybe, find a little bit of that irony, that dark humor in how carefully they designed something around such a serious topic. Okay, let's get into it. So you look at the simulation. Seems pretty straightforward at first. But digging into how it was made, that's where it gets really interesting. These developer notes, for instance. There was this whole issue early on with just labels, left and right on the 3D brain model.
Because it rotates, right?
Exactly. If it spins, is left still your left? It sounds small, almost trivial, but apparently it caused real confusion for users initially.
So getting that tiny visual detail right was super important to them for clarity.
It was. And the fix tells you a lot. They decided, okay, let's take those left and right labels off the main 3D brain picture itself. Instead, they put the selection clarity in the sidebar. And they used very precise terms there, anatomical hemispheres. So the actual brains left and right, no matter how it's spinning on screen.
It wasn't just fixing a small bug. It was like a core design choice. Let's make the user experience absolutely clear, unambiguous, especially with spatial stuff. It kind of highlights this focus maybe on controlling what you can control perfectly when the subject itself is, well, nowhere near perfectly understood.
And that's the fascinating part, isn't it? That massive effort, all that attention to detail to avoid this tiny potential confusion. Is this the left side or right side of a spinning graphic? And all this effort goes into a tool that in the end presents a really simplified, almost artistic take on something incredibly complex and mysterious like a seizure.
Right.
It's like, okay, we can't map the seizure perfectly, but gosh darn it, you'll know which hemisphere is which. What does that even tell us about how we approach understanding things like the brain, this need for clarity?
Well, I think it speaks volumes about wanting some solid ground, When you're dealing with something overwhelming, maybe you focus on making the immediate interaction, the controls, perfectly clear. It's like creating a little pocket of certainty. The interface clarity isn't just good design practice. It's maybe a psychological anchor for the user. They might not grasp the deep neurobiology from this tool, and the tool admits that, but they can understand the interface. So you build trust there. Right?
That's a really good point, a psychological anchor. Okay, so let's move from the careful engineering backstage to what you actually see and do. The official title is Brain Seizure Simulation, an interactive educational tool, and the stated goal: visualize different types of brain seizures for educational purposes with visual and auditory feedback, taking something invisible, internal, maybe scary, and making it external, something you can look at, interact with.
Exactly. And when you load it up, the interface is pretty clean. The main thing you interact with is this seizure type drop-down menu. And it's got a decent list: focal, generalized, and they helpfully add, used to be grand mal, then absence used to be petit mal, plus tonic, atonic, and myoclonic. Choosing one changes what the simulation shows and sounds like, trying to give a distinct feel for each type.
And then you've got the usual buttons, right? Start simulation, pause, reset, standard stuff. But then there's the play demo button. And this is where, honestly, it gets a bit darkly funny. This button lets you cycle through all available seizure types one after another. The prompt literally says, select seizure type and press Start Simulation, or press Play Demo to cycle through all types. And you just have to picture someone thinking, yeah, I got spare 10 minutes. Let's just watch the highlight reel of brain malfunctions on demo mode.
Yeah, it does sound a bit absurd when you frame it that way.
It's just so clinical.
Yeah.
Gamified almost.
Yes.
For something that's incredibly serious and personal for people who experience it.
It really is a strange mix. It kind of turns this profound medical thing into like a museum exhibit you can just browse through. Beyond that demo button, you do get more controls. You can toggle auto-rotate on the brain model, adjust sound, change the speed, make it faster or slower. Different view options, too, front, side, top, and these readouts for things like intensity, duration, active neurons, trying to put numbers on it, make it feel more tangible.
Quantifiable, yeah. Okay, so the big question, how does it actually look and sound? What does this simplified visual and auditory representation translate to for each seizure type? Let's break that down. Okay, first up, focal seizures. Tool says they begin in one area, localized symptoms. Simulation shows activity concentrated in one brain region, like a little storm in one corner.
Makes sense. Then generalized tonic-clonic, the old grand mal, affects the entire brain simultaneously. Loss of consciousness, jerking. Simulation goes for widespread chaotic brain activity, like the whole thing's lighting up erratically.
Then absent seizures, the petit mal, those grief episodes of staring. The simulation shows a temporary dimming of brain activity, like the lights just flicker off for a second, eerie almost.
Yeah, a subtle fade. For tonic seizures, the ones with sudden muscle stiffening, it shows sustained, intense brain activity that gradually builds up, like a power surge that holds.
And atonic seizures, the drop attacks, sudden loss of muscle tone. The simulation gets quite literal here. Rapid decrease in brain activity and particle dropping. You actually see simulated bits falling down.
A visual metaphor for the drop, yeah. And lastly, myoclonic seizures, those brief, shock-like muscle jerks. Simulation uses rapid, intermittent bursts of brain activity with jerky particle movements. Quick, sudden jolts in the visual.
So it's trying to create these distinct visual signatures. And to help you decode it, there's this understanding the visualization section, basically the legend. It explains the color coding. One color for normal brain activity, another for increased electrical activity, a brighter one for intense seizure activity, and then something for post-seizure suppression. A whole spectrum.
Right. And it also defines the movement pattern. Smooth rotation is normal. Chaotic movement, that's for generalized seizures. Localized activity for focal. Sudden drops map to atonic seizures, and quick jerks map to myoclonic. They're really spelling out the visual language they've invented here.
And the sound, this is where it gets really creative. Let's say creative. The audio feedback, normal activity gets soft tones. Sudden onset seizures get sharp sounds. Okay, maybe that makes sense. But then, for generalized seizures, that widespread chaotic activity, the audio is described as complex harmonies. Complex harmonies. Your brain is having a major electrical storm, and the soundtrack is harmonious.
It is a choice, isn't it?
It's amazing. Brief silence for absent seizures, it fits. And sustained tones for tonic seizures. But the complex harmonies, it just perfectly captures the sheer artistic license here, trying to make a medical crisis palatable, maybe even aesthetically interesting. It's wonderfully absurd.
Well, it does point to that fundamental challenge, right? You can't actually show or play the sound of raw neural firing in a way that makes intuitive sense to most people. So you have to use an analogy, metaphor. The goal probably isn't realism, which might just be noise or static or frankly disturbing. It's about creating a distinct, memorable pattern for each type, something your brain can latch onto for learning. It's interpretation, not replication.
Distilling the essence, yeah.
Yeah.
Which leads us right into the most critical part. The disclaimers, the big bold warnings that come with this tool.
Right.
Because after all this design, the colors, the sounds, the careful labels, they hit you with some very, very strong caveats about what this thing isn't.
Oh yeah, they are extremely clear. No ambiguity here. It says right there, this simulation is a highly simplified model, full stop, and then. It is not a medical diagnostic tool, nor does it provide medical advice. Absolutely crucial. And tying back to the visuals and sounds we just discussed, it states they are artistic interpretations designed to convey general concepts and are not precise scientific or medical models of brain activity.
Artistic interpretations. So after all that painstaking developer work on clarity for like left versus right, why hammer these limitations home so hard? Why the need to be so explicit, almost defensive about what the simulation can't do? What does it tell us about that line between educating and potentially misleading, especially with health stuff?
Honestly, those warnings are just responsible design. They have to be that strong. It's an ethical necessity. Think about it. You're putting a tool out there that visually represents a serious medical condition. You absolutely have to manage expectations and prevent misuse. People might see it and think, oh, that's what a seizure looks like inside. But it's just one interpretation, and a simplified one at that. So they draw a very clear line. This is for general concepts, for basic understanding. For real medical info, they point you elsewhere. They list resources like the Epilepsy Foundation, the WHO, NINDS, and underline, always consult with a healthcare professional. It's about safety and accuracy. Clarity in the UI, yes, but also clarity about the tool's fundamental limits.
Right. So wrapping this up, it's quite a journey. You start with developers obsessing over tiny UI details for maximum clarity. You end up with a tool that visually and audibly represents seizures in these really stylized, artistic ways, and then slaps on these huge warnings saying, hey, remember, this is super simplified. Don't take it as medical fact. It's just this fascinating tightrope walk, trying to make something complex and scary accessible, but terrified, rightly so. That the simplification might be mistaken for the real thing.
Yeah.
It's critical, it's kind of amusingly ironic, and it really highlights that tension between making things understandable and keeping them accurate.
And it really does leave you thinking, doesn't it? If even a tool like this, designed with such care around something relatively concrete like brain seizures, has to end with such strong warnings about being simplified and artistic, what does that really say about the massive challenge of truly understanding and showing what goes on inside our bodies? Where is that line between a helpful analogy, something that genuinely aids understanding, and an oversimplification that could actually, lead people down the wrong path? Especially now with so many digital learning tools out there. What do you think? How do we find that balance?
There is a human in the loop, just in case you were wondering. So if you have any questions, requests, complaints, likes, dislikes, eventually everything we do goes on to BioniChaos.com. So go check it out, let me know what you think. We do have advanced EEG signal simulators and things like that. A lot of fun. And obviously smash that like button.